Well, I'm going to talk a little bit about the history of how in Mexico we generate a reference database. So the name is Validating Information in the Mexican Reference Database using the ISBSG data. So the agenda that I've prepared is only 3 points. The first is how we collect the information for the Mexican industry. The second is how we made empirical validation about this information after after we collect the information for several projects, and then a conclusion. I mean, this conference is a kind of history of how we get now we now get a database. So as Pierre mentioned, ISBSG started in 1997. So this very interested group has now 23 years, and a lot of information that has been generated. For example, like reports and studies and the tool and several information via this kind of information generated by ISBSG has been positioned as the ISBSG as a world reference. So this is a very interesting issue. And from the Mexican perspective, we start the Mexican Software Metrics Association in 2015. So we only have 5 years. So I am saying that in the 2015 year, we have no data for the Mexican industry. So the idea in 2015 is to generate or to develop a baseline study of productivity and cost for the Mexican industry. That study was the first goal for the Mexican Software Metrics Association, starting in 2015. Invitation for all the companies and entities in the government was launched to obtain to gather information. We are looking for projects that was ending. I mean, we know all the information about the projects, and especially the effort involved, the phases, and some other features about the projects. The idea of this baseline study was to provide information to the Mexican software development industry to improve the knowledge, and to improve the knowledge in different point of view. First of all, the technical point of view. Okay, we need to know, for example, if a type of project with a specific life cycle will be more productive than other or something like that. But the other aspect was economic aspect. The economic aspect is because we need to define what is a unit cost, for example, in the industry. An issue for this study was focused on the customer perspective or the client perspective. And that means the information required for the project was the information from the customer's perspective, with the idea to become or to get a reference in the industry, especially for the cost or something like that. The survey to collect the information has 3 sections. Section 1 related to the project identification, what time of life cycle, technologies, database, operating system, and so on. The third section was related to information if the people that develop the project collect or measure the project and collect the information. The reality was that nobody answered this section for the first survey. So this two sections are very or strong related to the ISBSG questionnaire. The second section is about how the projects in 2015 in Mexico, nobody used Cosmic. So the projects were not measured using Cosmic. So we need to measure the projects using Cosmic, as Pierre mentioned in the introduction. The Cosmic is a national norm in Mexico. So we need to know the functional size. So the second section was created to get some kind of information in order to measure the software or approximate the software. I will talk a little bit later about it. Then the idea for defining the reference Mexican database, it was to create a benchmark repository that help us to measure the performance, make estimations, and make some kind of benchmarkings. However, we cannot avoid that this database will help correctly for the Mexican industry. However, we need to create a comparison between ISBSG. That is the reason why the survey was created using similar fields that ISBSG used, because the idea was to make a kind of comparison or benchmarking between the data we collect against the data with that ISBSG has in the repository. What kind of information we collect in the database? We are mainly focused in software functional user requirements. Why I am saying that we are mainly focused? Because, as mentioned, Cosmic was the national norm, that is NMX. This is the number in the national norm. So we can measure the Cosmic using a national norm. We can measure the functional size using a national norm that could be a reference for all the industry. That is the point to use Cosmic. However, there are other information related to the project that as non-functional requirements, project requirements and constraints. This kind of information was collected in variables, different variables. For example, as I mentioned, the technology used, programming language, database, whatever. So there are several variables related to collect some information about the non-functional requirements and project requirements and constraints, similar as ISBSG. But related to collect the information for functional size, we were using the approximation technique. Why using an approximation technique? As I mentioned here, we're going to use Cosmic, and we have some kind of information from the projects collected, but the information was not the functional size. The information was what kind or how many use cases, how many functional process, how many user stories, and whatever. So we need to use an approximation technique. The approximation technique, Cosmic was defined that could be used in 3 scenarios. The first is when a size is needed, but there is not enough time to develop the functional size using the standard method. The second scenario is very early or in the early phases of the project, when there is not enough information related to the requirements. What is the difference between these 2 scenarios is, in the first one, you have the full requirements defined, but you don't have enough time to measure all of them. And the second scenario is you maybe don't have the requirements, the functional requirements, detailed enough. So you have to approach or estimate the functional size. There is a third scenario that was defined by the Cosmic Approximation Guideline that mentioned that the approximation techniques could be used when the documentation, maybe you have a documentation that the user mentioned that is correct and is the full defined requirement, but the quality is not good enough. So if the quality of the document is not good enough to apply the full functional size methodology, you maybe you may be going to or will need you need to use an approximation technique to approach the size. So these are the main reasons why the guideline approximation technique mentions that we need to use the approximation. We are using the approximation because the second scenario. We collect information from the projects, but we don't have enough requirements definition. That is why we use approximation. Then we are looking for the earliest software sizing guideline with Cosmic, the aspect in the expert guideline. They mention in the guideline there are expressed or defined 15 approximation techniques. All of the approximation techniques requires a local calibration. What means local calibration? You need to improve or define these approximation techniques using own data. But the problem when you create the first database or first reference database is you don't have data. So the only technique that do not require local calibration is the EPCU approximation approach. In fact, this EPCU approximation approach was created because or tried to tackle this situation. We developed the EPCU approximation approach based in fuzzy logic. This mathematical framework help us to avoid the local calibration. Then we use the EPCU approximation approach to measure the functional requirements from the collected data in 2015. So after we get the data, the cycle defined was something like that. We promote the use of Cosmic or the collect information from Cosmic, from projects. We are collecting this information and try to create a database. And then the idea was to analyze this information in order to generate some kind of reports, specifically the baseline study here, and some other reports. But after we collect the information and we measure the projects, what was in that time the status? And we are mentioning here the status, but was in 2017. We spent 2 years trying to collect this kind of information. We collect finally in the first draft of the survey 398 projects only in Mexico from 2000 that was developed from 2012 to 2015. There are different technologies. They are using Cosmic, or we are using the approximation technique to obtain the functional size in Cosmic. They were using EPCU approximation approach. If we see this kind of projects, this number of projects that we have in 2017, and the data collect in Cosmic for the ISBSG, we have from 2010 and forward 303 projects. We were surprised because we collect a lot of projects considering the information available in Cosmic. If we look for the information in IFBook or maybe another methods, I don't know, maybe IFBook only, at the ISBSG database, there is a lot of projects because also IFBook have a lot of time. But in Cosmic, we have a set of projects, an interesting set of projects to make some analysis. Okay, then after we collect the data and we generate the reference, the Mexican reference database, the question was if we can trust in the data. Not about the statistical information, because that statistical information could be gathered from the data and so on. But I mean, what happened if our data could provide counterintuitive information? Then we need to use, or we try to validate this kind of information with the ISBSG experience or the ISBSG information. So what we done was to begin to replicate some kind of reports. Okay, these 10 reports were usually we have been replicated with our data. There are some differences. The first of the difference is that most of these projects, these 10 reports, sorry, was developed using IFPU, and we are using Cosmic. This is the first difference. So the other difference is that there are some projects, some papers, kind of old. Let me say, use that words. I mean, there are several years uh, where these developments were created, with these reports were created. So anyway, we try to use these kind of reports in order to validate, but we cannot validate the exactly data. We need to validate the behavior. We are trying to look, or we are trying to looking, we are looking for counterintuitive information, because this counterintuitive information could be a, could send a message that maybe the database was not correct built. So we create several studies. Now we can mention these studies. In fact, if I'm going to change interchange my page. I hope you could see the page. Let me see. Here is the homepage of the page of the AMMS, and we have been promote all these studies, so they are online now, these studies. So with these reports that we develop and they're online, are building using some other reports from the ISBSG, and we are now presenting some kind of validation that we made. Was more graphical or visual validation. The first that I need to explain is some issue that is mentioned in the report. That is the relative PDR. The PDR is product delivery rate, and the relative is for all the PDRs. You identify the median, okay, and then you use this median to obtain a relative PDR. If you have a very high PDR, will be from this side. If you have a low PDR, will be from this side. It could be negative below the median. So this is a concept that are using in some of reports of the ISBSG, and we are using here. So the first comparison is considering that I'm going to show you is with the report impact of software size on productivity. There was a joint report with the ISBSG from Keiper Jones and Rafer Consultants. It was developed in 2013. So in this comparison, we can observe in, I don't know if you okay, the red one line is this one is related to the ISBSG, okay, the median of the related PDR. So the blue one that is hiding by the menu of Zoom, this is the the Mexican reference database related to the study that we collect. So as we can observe here, the behavior is pretty similar. That represents that for the small projects, the PDR is higher than the biggest one. This represents the scale economies. And the behavior is pretty similar between the database. We also have a variation of the Mexican database and is without outliers. Without outliers is also similar with the ISBSG. So similar information or similar analysis like I am mentioned here was made with several projects, with several reports developed by ISBSG. For example, here we have the comparisons between PDR relative against the total effort. So with the total effort, the behavior is similar as the previous one. For the PDR are higher for the smaller project. Another comparison was for the analysis, the report developed in 2010, was the analysis of project duration by size and effort. So we have in the x-axis the effort, and we have in the y-axis the duration. The blue one is the Mexican information, and the red one is the ISBSG information. As we could see, the behavior is similar. Of course, there will be some kind of variations, but we don't have counterintuitive information. And this is a very, very representative of the how the software development or how the effort or how the duration are related to the functional size and also to the effort. So this is very important because represent some elements important. The database collect represent the information in a correct way. Maybe the specific data could vary, but this variation could represent several other information related to maybe the Mexican industry. So here we have again the functional size in the x-axis against the duration. And also the red one is the behavior representing by the ISBSG, and the blue one is the behavior from the Mexican database. I don't remember. Yeah, it's the same report. But we have here a 2017 report. The name is The Size Matters: The Effect in Project Size on Productivity in Software Development Projects. And in this comparison, we are evaluating or analyzing the relative PDR by project size. Again, the project size is defined here. The small is here. The average is here. And the large are here. So as we could observe, again, the behavior is similar. So this is important because we can validate that information is the information provided is aligned with the information provided by the ISBSG and represent correctly the reality. Maybe the data points or the specific point here to here could be different, but there are maybe another reasons, other circumstances that could generate these specific values. We have developed another report that integrates several reports developed by the ISBSG. For example, in this report from 2007, the outsourcing, offshoring, in-house, how do they compare? This is the report when we found the highest difference. And this is, in this side, we have the development by outsourcing. And this is the development in-house, okay? By the outsourcing, we have the PDR pretty similar. There is not too much variation. But in the PDR, when there are developed in-house, there is a huge difference. more than 100%. We need to go deeper in this because we know in Mexico that the software development in the government entities is very less productive than in the private sector. So we cannot directly say that this is a wrong value. We need to go deeper to research why this is value arise. This is a comparison between the effort by phases, considering the ISBSG in this side and the national database in this one. The first value is planification, analysis and design, the blue one, requirements specification, construction, testing, and implementation and deploy is the last one. So the main variations we can observe in these three parts. Okay, for the construction there is not huge variation. The higher variation was in testing and also in deployment. And in Mexico, it's well known that the first effort that the companies reduce in the software project development is the testing. So there is not counterintuitive against the reality in Mexico. Maybe we need to go deeper to validate this information because differ from the ISBSG. Again, we cannot say that was wrong information. We need to go further then. Here is the same comparison, but we have new development. No, for the new development this is the behavior. Also, the main difference is for the last phase of the life cycle. Yes, testing and deployment. The other phases are pretty similar. So that's all for this. We also have, we also develop. I mentioned here is that this study was in 2017. This is the name of the study. Okay, that is different from the previous one, 2007. This is the same for 2017, and this is another study that related to 2008. That their name is web projects. How are they different? And we observe here that the information in green is the ISBSG, and the information in blue is the Mexican information or data reference, Mexican database, reference database. So again, we can observe that maybe the higher variation is in testing. This is planification, requirements specific. This is planification, requirements specification, documenting or documentation, analysis and design, construction, testing, deploy, and some other effort documented. We can observe then that the highest variation is again in testing. This is for projects, web projects. Okay, the effort invested in each phase for web projects. And if we compare with no web projects, it's considering the same. The green one is the ISBSG, the blue one is the national, I mean the Mexican reference database. And we have also planification, specification, documentation, analysis and design, construction, testing, deployment, another one. We observe here more homologous percentage or effort invest. Maybe the highest difference could be something like this and specification. Okay, but there is not too much difference in neither. So, in conclusion, In Mexico, we began the collecting information in 2015. We apply the EPCU approximation approach defined by Cosmic to obtain the functional size. We get approximately near to 400 projects in 2015, but currently we have around 500 projects. Looking to validate the reliability of information, we use some reports or studies developed by the ISBSG, and we replicate them with our data. The behavior we observed was pretty similar, and we do not observe some counterintuitive behavior, but the difference could be assigned by several reasons. We are comparing against studies developed using IFPUG mainly, not Cosmic. Of course, the way of work in Mexico should be different to other countries, could be, and the other element could be that some projects in the replicated studies was older than the projects that we consider for the Mexican database. A relevant issue from our perspective is that we validate again that the EPCU approximation approach works correctly. I mean, in an easy way, really fast, and without need to develop a local calibration. We can get a correct functional size or near to the reality from the functional size. That this allow us to generate some kind of studies to move forward to evaluate the information in projects from the two perspectives, economic perspective and also for the technical perspective. So now we have a reference database in the software, Mexican software industry, development industry. And of course, this study could be replicated for other countries, especially when they have no local database, in order to get a national reference that could be compared against international reference. So I think we are really on time. I don't know if there are some questions. I am ready to answer if somebody have questions.
Thank you, Francisco. Really interesting to see, and especially the observation and the fact that you have found that it's very close to each other, the study that you have done and the studies or the reports from the ISBSG database. And as Bob said, it's not the exact metrics is not important. You have to be on the ballpark, and that's what I've been using since I started with metrics in the 80s. You have to be quite close enough, and that's good enough. And so, do we have any questions coming up?
So Pierre, we do have one question that's already come up. The first one, actually now we have two, from Sergio. Did you create any documented procedure or process that supported the execution of the study that could be used to repeat the study another time?
Yes, not as formally as a specific procedure. Some of these, I mean, we are using this procedure or this study to write some conference papers. So there is a general overview of the procedure. but there is no problem to generate this procedure. I mean, we are usually using as a consultancy, and in any client we replicate the procedure. So maybe there is not write down, but it could be easy to do that. I mean, we are usually replicate this study in each client to generate the local database, and is well enough define the procedure to be replicated.
Perfect. We also have a question in the chat window. How many Mexican companies participated sharing information for collecting the information?
Oh, I have no the number right now. I want to say the number by memory. I have not the correct number right now, but I think there were around 10 companies in the private sector and 8 companies, or maybe 10 companies also in the government. Especially the government, I have not I'm not sure about the number, but especially because with the 100 projects now, we have involved another entities. So I have not the right number, but if you require the number, I can get it from our repository manager.
Wonderful. So we'll email the person in the chat that asked the question, if you can get that. Excellent.
Yeah, no problem.
Any other